Namaskara. We will continue our discussions on more for less for divide and conquer algorithms. This is an interesting example. We will present a slightly simplified version of the problem. It is a highly simplified version just to formulate as a more compact problem we are doing this. You might have already experienced in real world the recommendation system. For instance, if you have bought anything in Amazon, people who bought this have also bought the following and so on. Or if you have subscribed to certain movie channels, people who have seen this movie have also seen this. So, some recommendations are given to you by the system. How does it arrive at it? Here is a very simple model. So, it is going to ask every viewer a rating of the movie. So, that way, for example, for the past 10 movies or 8 movies that you have seen, your ratings are something like some movie you liked it a lot, and so let us say M1, M2, okay, let us take 7 movies. Among these 7, okay, this you this is the one you liked most, this you did not like at all, this is the least of this, and this is okay kind of a thing, and so on. So, that way this will be a permutation of 1 to 7. So, a permutation is going to model your ranking. It has your ratings also. So, based on the rating, it has got an associated permutation, okay. And suppose there is another person who also rates the movie, the 10 movies seen by several others would have seen these movies, and they would have also given their ratings, okay. Let us say let us assume that the movies are labeled as per your ranking. In other words, M1, M2, M3, M4. Your rating is 1, 2, 3, 4, 5. Let us assume that these are the 7 movies rated by you as 1, 2, 3, 4, 5. But for somebody else it could be different. For example, for him this movie could be 6, and this could be 2, this could be 1, this could be 5, this could be 7, this could be 4. This the rating by another person. Yet another person may rate in a different way. Each rating in this way is a permutation. Okay, 3, 5, 7, 1, 2, 4. This is another rating. In this way, different people. Now, you can see that a person completely agrees with you if his rating is also 1, 2, 3, 4, 5, 6, 7. His rating completely agrees with you. Whatever you feel as best, that person also is feeling the best. Whatever you feel is terrible, he is also feeling the worst. Perfect agreement with your taste. A person is completely contradicting if his ratings are something like 7, 6, 5, 4, 3, 2, 1. Just the opposite. What you call as the best, he calls as worst. What you call as worst, he calls as the best. Totally different taste. Okay. So, we would like to know in a given set, okay, how many people have taste somewhat similar to it. okay, similar to your taste. So, we call a pair in a permutation as inversion if I is less than j, but pi is greater than pj. Okay. I is less than j, but pi is, for example, this is I and this is j. I is less than j, but this pi is greater than pj. It is out of sort. Okay. You rated one movie to be worse than the other, but the other person has rated it the other way. Okay. So, there is an inversion, means there is a difference of opinion here. If there is no inversion, okay, like this, if I is less than j, pi is also less than pj, same taste. But if there is some difference of opinion, it will be reflected by an inversion. While you will say that this is better than the other one, the other person will say that is better than this. Your rating is given by this indexing scheme. So, there is a movie sequence and the rating by you is given by that. Any permutation will model the rating by other person. Now, if the number of inversions is 0, there is no inversion. I less than j means pi is less than pj for every pair, no inversion pair. Therefore, this is perfect alignment, 0 inversion. Look at this, everything is inverted. Okay. So, this is going to have maximum number of inversion, it is going to have maximum number of inversion. So, I is less than j, but pi is greater than pj in a permutation p1, p2, etc., pn. This is called an inversion pair. Inversion count is total number of inversion pairs. Count the total number of inversion pairs and that will give you inversion count of a permutation. So, inversion count of a permutation is the total number of inversion pair in it. Okay. So, we can take let us say 4, 3, 7, 5, 1, 6, 2. How many are to the left? Smaller index, larger value, none. How many for this to the left? I is less than j, but pi is greater than j, 1 value. For this, how many are to the left and larger? Nobody is larger, 0. This one, 1. This one, 1, 2, 3, 4. And this one, 1. And this one, 1, 2, 3, 4, 5. So, each position defines the inversion count with respect to that position. How many are to the left and larger? Okay. I less than j, but pi greater than pj. I am using strict inequality because it is a permutation, all numbers are distinct. So, the inversion count is 1 plus 1, 4, 6, 7 and 12. So, the inversion count for this permutation is 12. So, what is a direct simple algorithm to find the inversion count? Very simple. Find the inversion count for the ith position. Okay. So, ICI will give you the inversion count of PI. Start from the ith position, go to the left, start from I minus 1 and keep going to the left. Count how many larger numbers you are finding. That is what we did for 1. This is larger, this is larger, this is larger, this is larger. So, we wrote 4. For 7 we went to the left, nobody is larger. So, we wrote 0. So, starting from every position, go to the left, count how many are larger. So, ith position will have a complexity I minus 1. You have to scan all the I minus 1 positions, find out how many of them are larger. Therefore, inversion count I takes I minus 1 steps. That means naive direct algorithm will take order n square steps. For each position, keep scanning to the left, find out how many are larger and that count, add all of them and that will give me the inversion count. So, now we are going to see a divide and conquer algorithm. Okay. How are we going to design a divide and? It is very simple. Anyway, you can take any set of integers in an array and we can ask this question. Okay. Let us consider an array A1 dot dot n. How to find the inversion count for this array? Instead of permutation, you can assume that all numbers are distinct. Okay. You can take any n distinct numbers. For each I less than j, if ai is greater than aj, it defines an inversion pair in the array. In any array, we can define the inversion pair. So, what I can do is my permutation I can give in an array P1n, m as usual is floor n by 2. Inversion count 1 in P1 dot dot m. How many inversions are there in this part of the array? How many inversions are there in the remaining part of the array, in the second half? Okay. So, I have an array. In this part I have computed the inversion count. In this part I have computed the inversion count. Now I have to compute the cross count, cross inversion count. Okay. Cross inversion count is to be, what is a cross inversion count? See, there may be a number here larger than the number here, but those things were not considered, because when you are solving the divide and conquer, only this part P m plus 1 to n is considered. There are a lot of values to the left of this, they may be larger, but you have never compared them. Similarly, for this one, all numbers here are considered. It has nothing to do with the other part. You are independently solving this. So, you do not know how many values on the right is having some larger values in the ignored part. Okay. For example, if I have 4, 7, 1, 6, 5, 3, 2, 8. Okay. I will write the inversion count 0, 0, 2, 1 for this part. For this part 0, 1, 2, 0 separately the inversion. However, 5 has got these two guys here larger, that I have to figure out. Similarly, 3 has got all these things are larger. These are called a cross count. Cross count is how many elements in the left are larger than the elements in the right. Therefore, I have to compute cross count j, compute cross count j for each j in the second half belong to m plus 1 dot dot n. For each of this I have to compute the cross count j and that cross count is sigma cross count j of a cross count j of j equals m plus 1 to n. This is the cross count. What is the total number of inversion count? Now, inversion count is IC1 plus IC2 plus cross count, all these inversion put together. Okay. What is the maximum inversion count possible? What is the maximum inversion count possible? N, n minus 1. The permutation in reverse, totally opposite to your taste. Then this is 0, 1, 2, all the 2 are, all the n minus 1 are. So, sum will be n times n minus 1 by 2. For example, for 8 it will be 8 times 7 by 2, n equal to 8. This is 4, so 28. So, the maximum number of inversion count is 28. So, the company would like to figure out the number of people who have taste somewhat similar to your taste. What is the absolute agreement with your taste? Inversion count 0, but that may or may not happen. It may also happen, but we will give a small allowance, 10%, more or less your taste. So, 10% of this is 2.8, let us say 3. So, I will find out, or the company will find out how many people have inversion count over the same 8 movies that you have seen in the last, inversion count less than or equal to 3. That means it is trying to figure out the permutations with this ones, and all those people have got a very similar taste to you, somewhat similar to you, quite similar to you rather. Okay. The total disagreement is quantified by 28. Complete agreement is quantified by 0. In between values will tell you the quantum of disagreement. If it is 3 or less than 10%, less than or equal to 10%, it is more or less they agree. So, whatever is the 9th movie that they have seen, or whatever is the recent movie seen by those people who have a in that the most frequent one it will pick, and then the system will give you as a recommendation. People who have liked, who have seen the same 7 or 8 movies of what you have seen, have also seen this. From where, how does it identify the 9th movie? It is identified as the next major frequency count movie among the people who have got taste somewhat similar to it, similar to you. Therefore, this is an interesting problem, finding the inversion count for a permutation. You can generalize this for inversion count of any array, inversion count of any array with distinct numbers. Okay. And because of the interesting application I presented it this way, we can. Now, if I have to find the cross, this is where the problem comes, cross count. Okay. Here, what I did was, for every element I scanned all the elements in the left, figured out which of them are larger, which of them are smaller. So, that way cross count may take n by 2 times n by 2. So, your naive algorithm will be T of n is twice T n by 2 plus n square by 4, and this will be order n square. This is bad. We had a divide and conquer algorithm, but this is, its complexity is very similar to the complexity of direct algorithm. In fact, this has got a lot of things to do, splitting the array, conquering, recursive calls, then combining the solutions. All of them are taking place, and it is n square algorithm. So, we will see what is the major problem here. The major problem is cross count. Cross count computation requires you to find all the larger element in the left. Okay? That is what we did for 5. What are all the elements in the left? This you are doing by examining all the items. Suppose the items are sorted, okay? Then we can speed up this process. You do not require the scanning. Okay? Let us consider the same example. Suppose I sort it as 1, 4, 6, 7, and here I sort it as 2, 3, 5, 8. Suppose I sort the left half and the right half. Still the values are there in the left half and right half, but they are sorted. I have not changed I have rearranged in the same half. Now I am going to, earlier I was comparing 2 with 4, 7, 1, 6 all items. I have compared 2 with every item. But now when I compare 2 with 1, I know this is smaller, and then when I compare 2 with 4, 4 is larger. Now this is sorted. Therefore, all further items are sorted, are larger. Therefore, all these things are larger. Okay? Therefore, I can immediately write this as 3. I am comparing only with this. If I want to find the cross, compare 5 with 4, 7, 1, 6, and then I will determine this as 2. Compare 3 with 4, 7, 1, 6, again n by 2, right. This will give me 3, again this will give me 3, this will give me 0, cross. This is taking n by 2 times n by 2. But I am now going to sort. When I sort, if I compare 2 with 4 and if I find it to be larger, all other things are larger. Okay? You can see the similarity of the way in which I am working and the merging routine. If I want to merge two sorted sequence, I will compare the elements from one sequence with the other sequence. Let us say I have two sorted sequence A1 dot dot n, B1 dot dot n. A is sorted and B is also sorted. Suppose I want to merge, then what do? I compare AI with Bj. If AI is less than or equal to Bj, this is a smaller value. Okay? This is a smaller value. So, how many values are smaller? In the merged sequence, I will have all the smaller A values are written before Bj is written. That is because if A is less than or equal to Bj, copy Ai in the C array. This is the act of merging. This is the act of merging. What you do is that you move that into the C array because it is smaller than current Bj. All the smaller values are already been moved. So, you are going to move all the values that are smaller as long as A is less than or equal to Bj, else A is greater than Bj, else Ai is greater than Bj. This implies Ai plus 1 up to An, all these values, all n minus I plus 1 values, all are greater than Bj. Because A is greater than Bj, A is sorted. So, from Ai onwards everybody is larger. Okay. So, I know how many elements in the left are larger than the elements in the right. For each index, all right. So, we are going to simply execute the merge routine. Okay? You simply execute the merge routine. You do not have to obtain a merged sequence, just apply the merge routine. All you do is just do this in the part. It counts the what is known as cross count for j. So, I have I equal to 1, j equal to 1. I have A 1 dot dot n, this is the left half sorted, B 1 dot dot sorted. While Ai is less than or equal to Bj, I equal to I plus 1. The smaller values are all skipped over. All smaller values are skipped over. The moment you find a larger value, I equal to I plus 1, okay. Else while sorry, not if I must if A is less than or equal to Bj, skip that. We are not interested in smaller values, we are interested only in larger values. I equal to I plus 1. Else cross count j for Bj is n minus I plus 1. If Ai is less than or equal to Bj, I equal to I plus 1, else this is what is the core thing to be done. Else C and j equal to, go to the next one, next Bj value. So, all the smaller values for Bj minus 1 will be smaller than that, you can ignore them, you do not use them for counting. So, for any Bj, if a particular Ai is larger, you know that Ai to An all of them are larger, therefore, I can get Cc j like this, okay. I can get Ccj immediately like this and then go to the next one. Therefore, this will become the core in the while loop. While the merging routine, while I is less than or equal to n and j is less than or equal to n, this is what you have to do. Keep moving out the smaller element, it is called a sorted sequence. So, it is like a merging routine, except that we are not interested in merging here. All we are interested in is that ignore the smaller values, count only the larger values. How many in A are larger than the current Bj, okay. That is cross count Cj. Now, the whole cross count, so the whole cross count can be computed in this fashion, and this, so with some initializing we can do the cleanup very easily. You can have a step like cross count equal to 0, cross count equal to cross count plus n minus I plus 1, that is the Cj's you can keep adding. If this is the case, I equal to I plus 1, else, so one of the sequence should be over, right. Whichever sequence is over earlier, you can stop with that process. Therefore, it is just a merging routine, and therefore, I equal to 1, j equal to 1, cross count equal to 0, while I is less than or equal to n and j is less than or equal to n. This what if ai is less than or equal to bj, then I equal to I plus 1, all smaller values you ignore, okay, else C equal to C plus n minus I plus 1, all these values are larger, and j equal to j plus 1. This is what you want to do, cross count between a 1 dot dot n and b 1 dot dot n, where a and b are sorted. We call this algorithm as cross count A B, cross count for two arrays A B, okay, cross count for two arrays. For sorted arrays A and B, cross count for sorted arrays. So, now let us look into our inversion count problem. Inversion count problem, inversion count, okay. You are given a permutation and your inversion count should be output in a variable called IC. Okay. If n equal to 1, IC equal to 0, there is no inversion, right. If n equal to 1, IC equal to 0, else m equal to floor n by 2, inversion count for permutation 1 to m, this array you call it as IC1, in count p m plus 1 dot dot n, you call it as IC2. Now, you have to find the cross count, right. You have to find the cross count, but the cross count, if I simply work with the p and with these two arrays, it will be n square. So, what I do is that sort p 1 dot dot m, sort p 1 dot dot m. You can use heap sort, it leaves the sorted sequence in the same, sort p m plus 1 dot dot n. So, you have two sorted sequence. Now, cross count of these two arrays p 1 dot dot m and p m plus 1 dot dot n. Okay, this is cross count. Now, IC equal to inversion count 1, inversion count 2 and cross count. Now, if you look at the complexity, this is T n by 2, this is T n by 2, this is n log n, this is n log n, n by 2 elements. So, and cross count is linear, it is like merging. So, it is n, this is order 1. Therefore, here you have T of n is 2 times T of n by 2 plus O n log n, and this has a solution O n log square n. So, it is much better than n square algorithm. It is much better than n square algorithm. We will see how this can further be improved using more for less idea. Okay. So, we will continue our discussions in the next session. Thank you.